This is part 2 of lesson 3.2 quadratic functions. In part 1, we talked about the characteristics of quadratics. We talked about the x-intercepts. We talked about the y-intercepts. We talked about the line of symmetry in the vertex. We spent a lot of time talking about finding the vertices and x-intercepts, and we used the quadratic equation. Part 2 will be mainly about the two forms of the equations. One is general form, one is standard form. So pay attention to how we go back and forth from standard to general and general to standard. You'll find out that standard is very conducive when you know the vertex. And so let's have fun here. Start talking about the two different forms of quadratics, which we already did. Talked about this standard form, giving a preview. Standard. And this one was the general form. This was that I told you about the opposite of b over 2a. That's how we find the line of symmetry. It's also the first place of the vertex. And then moving on, if you take this answer and plug it into the function, you get the other piece of the vertex. So as I was telling you before, your vertex is going to be always opposite of b over 2a. And that means if you plug that in, that gives you f of opposite of b over 2a. And that's what they just did. That's what they're doing here. Finding out the x component and the y. All that did was, again, it found the x and the y. So I'm going to say that's x, comma, y of your vertex. Yeah, I'm going to stop. That's the end of part 1. That's enough. Okay, welcome to part 2 of quadratic functions. And the last thing I'd mentioned to you was about the combination of the general form of a quadratic function and of a standard form. To remind you, the f of x equals to ax squared plus bx plus c is the general form. That's how I like to see my quadratics, because it just shows that it's a polynomial, second degree. And if you realize that x squared is the square is your highest, x to the 1 is the next variable decreasing exponent, and then the c is actually times an x to the 0 power, because anything to the 0 power is 1. That's the general form. It's just a polynomial in the correct standard form of a polynomial, in the sense that you always put the highest degree first, and the other variables have a decreasing exponent getting lower and lower as you end. For instance, 2, 1, 0. That's the form of a polynomial. That's general form, and I'm quite comfortable with that. But then every once in a while, and especially when we're doing this unit, we look at another way of looking at the same polynomial. And a is still in the front, but I have a set of parentheses. And this should look familiar when we were graphing absolute values and things like that. X minus h squared. Remember when we were doing the opposite of left and right, when you see minus h and h was a positive number, we'd be going to the right. That's the same thing as we had before. And then outside of here, outside of the squaring of the minus h, we say plus k. Now k could be negative. And if k is negative, you would see minus k. And then we'd be moving my parabola down. If k is positive, plus a positive number would be moving your parabola up. So these directions for how to is how to look at a parabola in both standard form. I better name this one then. This is standard form, and this one was general form. Now, what's the advantage of standard form? We know right away where the vertex is. We know that your vertex will always be, in this problem, whatever h is, okay, h comma k. Whereas when I have my general form, that's a lot more complicated, because if you recall the end of the last part 1 lesson, the x value of the vertex was opposite of b divided by 2 times a. So you can see why that is what we would use, because here's my a and here's my b clearly defined. So I can find where, if I had a parabola somewhere here, I know that this line right here, this imaginary line going through the vertex, I'm looking for this x number. And then how do I get the y value? How do I find out what the whole ordered pair is? I'd have to plug this in to the function, whatever this value is, which, by the way, is minus b divided by 2a. I'd have to plug that into the x, and it's not fun, because look at, you're going to have to plug in this answer here and here. So it is a handful. It is a little stressful. So my vertex in this case would be, and I said this in the other presentation, the x value is minus b over 2a, and then I'd have to plug that in, so f of minus b over 2a, whatever answer that was, I'd have to plug it into the two x's that are in there to get the vertex. Now, inside these steps, they talk about, well, what if a was negative? Well, if a is negative, in either one of these formats, we know the parabola goes upside down if a is negative, because there's a negative in front. It doesn't matter what kind of number it is, -2, -3, even a plain -1, which we would just put a negative in front, goes down, upside down. A positive a will go up, right side up, okay? Okay, let's work on example 2. Write the equation of a quadratic function from a graph. Okay, well, there's probably more than just that. Let's see if there's anything else. Write the equation in the form. Write the equation for the quadratic function in figure 7 as a transformation of f of x equals x squared. Okay, well, they're just saying that your parent function, x squared, has some movement. That means your vertex went up, down, left, and right, whatever the case is. And then it says, express the formula and simplify in terms of the equation in general form. So they're giving us a hint to use standard form first. And so standard form, let me remind you, is f of x equals to some number. I know it'll be positive because it opens up, so x minus h all squared minus k. I'm sorry, plus k. The minus goes inside the parenthesis because it does the opposite, left and right. If h was positive, we'd be going left. If h is negative, we'd be going to the right. In this case, my vertex is down here. So I know my h is going to be positive in order to say minus a number. So my h is going to be positive. So the hk, my vertex, is h comma k. So I think I was correct at where I was suggesting the vertex was. It has to be on this line right here. And that is x equals 2 and negative 2. So therefore, I know that I'm going 2 to the left, 1, 2. And then going down, I'm down here at 3, negative 3. So my vertex negative 2, negative 3. My vertex is negative 2, negative 3. So let's plug in what I have. F of x, some a that I don't know. X minus what? What's my h? A negative 2. Plus what? Plus my negative 3. Now you know and I both know that these two minuses together, they go together to make a plus, and this plus minus becomes a negative. So f of x, sum a times x plus 2 minus a 3. Now, f of x just means y. Just means y. So if you want to look at it as y equals to a times x plus 2 minus 3, that's fine, because the vertex, this is my x, and this is my y. But I can't plug it in again because I've already used it to find a. So I need a different x and a different y, which where am I going to get them from? Anywhere in the picture that you can identify a perfect point. And you may find a different one. That's not a perfect point. Let me put a dot there. This is not a perfect point because it's not at the cross. This is not a perfect point. This is not a perfect point. It's so close, but it's not good enough. I don't see a perfect point till I get to right here. Oh, there it is. There's a perfect point. 0, negative 1 is a perfect point. So I'll go over here and I'm going to use the point, not this one, because I've already used it. I'm going to use 0, negative 1 for my x comma y. Plug it in. My negative 1 is the y. I don't know what a is. My x is going to be a 0 plus a 2 minus a 3. Forgot to put my squaring. I don't have it down on any of them. I should be in trouble. Lost my squaring every single time. That's one way to make a big mistake, but I'm glad I found it. So that turns into negative 1 equals to a, and then a plus 0 plus 2 is just a 2, and 2 squared is a 4. So I'm going to back up and take off that a. I think 4a minus 3. I will now add 3 to both sides, and negative 1 plus 3 gives me a 2 equals to 4a. That means a has to be 2 over 4, which is 1/2. So here is my equation in standard form. F of x is 1/2 times x, what was it, plus 2 squared plus minus 3. There's my standard form. Unless there's a mistake. Now, they're playing dirty. They're saying, oh, and that equation is good enough. Let's do general form. So let's go over here. Now we're going to do this general form here. This is a very good example. You should be getting this down for sure. Practice it 5 times at home all by yourself. I'm going to work on general form now. General form. I'm going to get my f of x. I'm going to put standard first. Is my 1/2 times x plus my 2 all squared minus a 3. In order to get the a, the b, and the c, you have to break this thing apart. And the first thing I'm going to do is take care of x plus 2 squared. Feel free, you want to do it on the side. X plus 2 all squared means x plus 2 times x plus 2, and use your FOIL. We've done a lot of foiling already, so I'm not going to baby you. I'm going to do my x times x is x squared, x times 2 is 2x, and then this is a 2 times x also. So 2x plus 2 is 4x, so x squared plus 4x. That's my outer and my inner together, and then my last two terms is plus 2 times plus 2 plus 4. There it is. So f of x is 1/2 times x squared plus 4x plus 4. Don't forget the minus 3. Now we have to get rid of that 1/2, and not get rid of it. We're just going to share it, because sharing is caring. So we will distribute that 1/2. Oh, not to the minus 3 though. Only what's in the parentheses, only what was here. And I lost my color again. Only what's in here. So that gives me a equals to 1/2 times x squared. 1/2 times 4 means half of 4. Turns into plus 2x. 1/2 times that 4 is also 1/2. I'm sorry, 2. Bring down the minus 3. So final answer, f of x equals to 1/2 x squared plus 2x minus 1. There's my general. We know what a is. A is 1/2. B is 2. C is a -1 if I needed it. So let's move on here. Put everything on the screen there. Is a lot of work. Okay, there's my example 2, and it looks like, looking if I made a mistake, I had the same A, and I have the same equation down here. So that means I had the same standard form as well right here. So I have it all. I'm proud of myself. Okay, try it. This will be all on you, but it's a real world application. It's got basketball in it. It says here, a coordinate grid has been superimposed over the quadratic path of a basketball that's in our figure. Assume that the point -4, 7 is the highest point of the basketball's trajectory. That's its path. Find an equation for the path of the basketball. Does the shooter make the basket? So that's a question we'll answer at the end. I know some of you are already probably making a speculation without even doing any work. So I'm going to use standard form. F of x is some a that I don't know, x minus h squared plus k. Remember, hk is the vertex. And if they told me right up here that the highest point is -4, 7, I'm looking at the grid, and I can see that this is my x-axis right here going across, and then this must be my y-axis. Okay, so -4, 7 would be left 4, 7 up. 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6, 7. It's right there. That's your vertex. So the vertex is negative 4, 7. So I'm going to plug that into my HK. So here goes. F of x, some a that I don't know, x minus a negative 4. We've talked about that. X minus a negative 4 becomes x plus 4 all squared plus the 7. Now, this doesn't mean much to us because we need another point. So I'm looking at those basketballs, trying to find one that I could use as a good ordered pair. And I see one right here. It's a perfect point. That looks to me like negative 1, negative 2, negative 2, and we're going up 1, 2, 3, 4, 5. That point is negative 2, 5. Negative 2, 5. I hope I'm right. So I'm using negative 2, 5. I'm going to plug those in as my x and my y. And so this is my y and this is my x. So I'm going to plug them in. 5 equals to a. X was a negative 2 plus a 4 all squared plus the 7 outside. 5 equals to some a. Negative 2 plus 4 is a 2 being squared plus 7, and 2 squared is 4. So that gives me 5 equals to 4a plus 7. I just switched them around. Subtract 7 from both sides. That gives me a negative 2 equals to 4a. Divide both sides by 4, and I get a is a negative 1/2. So here's the equation. That was one of the things we want to do. F of x equals a negative 1/2 times x plus 4 all squared minus 7. There's my equation. Now, the question was, will we make the basket? And I'm sure you were already thinking about this before. Trying to get rid of this line so I can see it clearly. And think about it for a minute. If this is my vertex up there at the top, that green dot, I'm going to probably cover it back into a black here. If that's my vertex, and I didn't color it, did it? It keeps staying green. Try it again. No, it doesn't want to draw no more. Can't see erasing. There it goes. So think about that being where the line of symmetry is. That I don't want to be in black. My line of symmetry would be this line here. And this parabola, you're only seeing part of it. You're only seeing where the ball is going from the person's hand. And the balls, you see, the pictures were like a lot of picture of the basketball moving. Think about how far we are away. And that's the middle of the graph. We're clearly 1, 2, 3, 4. I'm going with 4 away. 1, 2, 3, 4 away. We're up at 7, but we don't have to, that's where we are now. Let's look where the basket is, right here. Let me change that to a different color. and I'm not doing any math on this part, I'm just looking at it, saying the basketball is here, basketball rim. Okay, so how many is that? 1, 2, 3. 1, 2, 3. Will that basketball make it? I think not. We will call that an air ball. If you disagree with me, give me a good reason. How to. This is just given a quadratic function in general form, find the vertex of the parabola. I've already talked about this. General form is the x equals 2, or f of x equals 2, ax squared plus bx plus c. So if you have numbers, then we know that the vertex is going to be the opposite of b over 2a is the x part, comma, the y value is if you plug this in to the function, it plugs into here and into here. So it's going to be f of minus b over 2a. That's it. That's the y value. So we're going to probably practice this. Find the vertex of this quadratic equation. It's better that we practice it. So f of x is 2x squared minus 6x plus 7. A equals to 2. B equals to a negative 6. C is 7. Just like when we did the quadratic formula, label those constants that are in front of your variables, and then the one that doesn't have the x because the power would have decreased to a 0. So let's find out what, if my x value of the vertex is opposite of b over 2a, that gives me opposite of a negative 6. Opposite of a negative 6. All over 2 times a, which is 2. That turns into opposite of a negative 6 is a positive 6. 2 times a 2 is a 4. 6/4, that reduces to 3/2. So now I take my 3/2 and I calculate f of 3/2. So plug it in. So it's going to be a 2 times the x squared. So that's my x right here. So it's going to be 3/2 all squared minus the 6 times 3/2 plus the 7. So 3/2 squared means both of those numbers, the 3 and the 2, both get squared. So equals to 2. 3 times 3 is 9. 2 times 2 is 4. 9/4. That's after I squared it. And then this 6 times 3 has to be 6 times 3 all divided by the 2. So it's minus 18 divided by 2 plus 7. So let's go back to b. Let's finish simplifying. 2 times 9 is 18. 18 over 4 minus 18 divided by 2 is a 9. 9 plus 7. So 18 over 4 turns into 9/2 if I reduce it. 9/2. And then minus 9 plus 7 is a negative 2. I'm going to make them the same denominator, so I'm going to multiply this 2 by a 2 divided by 2 to give me the same denominator. That gives me 9/2 minus 4/2, which gives me the final answer of 9 minus 4 is 5/2. So there's my vertex. My vertex will be 3/2, comma, 5/2. And what did they want me to do? Rewrite this quadratic in standard form. Well, that's easy because I already have the vertex. I already have A2, by the way, I believe. I say I already have the A because here goes. Why am I telling you this? F of x it has to be an A times x minus h all squared plus k. So here's my h, here's my k. F of x is A times x minus 3/2 all squared plus the k 5/2. Now, I already have the A because it's the same A as when I did this up here. It's the same A. So we're done. F of x is a 2 times x minus 3/2 all squared plus 5/2. There it is in standard form. Well, why was that fun? Let's see if I'm right. Let's see if I'm right. I found my h. 3/2. That's what I had. K is f of h, which is f of 3/2. Let's see, what do we get? 5/2. So put it all together. X minus 3/2 squared plus 5/2. Same answer. Oops. And this is, what is this talking about? Try it. I'm not going to do this one, but you're just going to write this equation in general form, which means you're basically, well, it's actually already done. They're not telling you to do it then in standard form. I'll do general with you real fast because I said it's already done. It really is already done. G of x, I believe that's what they're using, G. The only thing is they don't have it in the right order. You need to put the x squared first. That's there's a 1 in front of it. X squared. Then the minus 6x goes next, and then there's a positive 12 goes here. There is your general form, okay? Now, you are supposed to put it in standard. That means find the vertex. And realize A is already going to be a 1. So find the vertex and plug it into, I don't want to use F because they're not using F right now. They're using G. So G of x has to be the A, which is a 1. So I'm just going to leave it blank. X minus h all squared plus k. So just find the vertex, hk. And if you come to me and show me your work, maybe I'll give you extra credit. Example 4, find the domain and range of this quadratic function. Just find the vertex. Just find the vertex. Because we already know what the domain always is. The domain for all quadratics, those parabolas, are all real numbers. So it's going to be negative infinity to infinity, or all real numbers. Now, the range depends on where the vertex is. And does this parabola open up or does this open down? Well, there's a minus here. It opens upside down. So if you find the vertex, h comma k, then that k is the highest it's ever going to go. So your range is going to be, here's half your answer, negative infinity all the way to k. The lowest is negative infinity all the way to k. So we just got to find the vertex. Okay? So this is one of the examples, so let's do it. A is a negative 5. B is a positive 9. And C is a negative 1. What do I need for the vertex? First, I need my x equals minus b divided by 2a. In this case, b is a 9. So minus 9 divided by 2 times a negative 5. They're both negative, so it turns into positive. 9 over 10. Or you could say 0.9 if you wanted to. It looks a little prettier sometimes. It might be easier to use as 0.9 now that I think about it, because I need now to go and find the, that's my x value is my h. My k value will be f of the h number, f of h. In this case, f of 0.9. That might be easier to do, so here goes. F of 0.9 must be a negative 5 times 0.9 squared plus 9 times 0.9 minus 1. You might want to use a calculator, because I have a feeling a lot of you guys will have trouble with 0.9 squared. But 9 times 9 is 81, and it has to have 2 decimals, because 0.9 has a decimal, the other 0.9 has a decimal, that's 2 decimals. So we're looking at negative 5 times a 0.45 plus 9 times 9 is 81, but it has to have 1 decimal place, 8.1 minus 1. And negative 5 times 0.45 is going to be negative. 5 times 5 is 25, carry the 2. 5 times 4 is 20, add the 2, that's 22, with 2 decimal places. So it's going to be a negative 2 point, let me do it black, negative 2.25 plus the 8.1 minus 1. Just use your calculator and finish that up. A negative 2.5. I can do a negative 2.5 minus the 1. That'll give me a negative 3.25 plus 8.1. Whatever that gives me. Whatever that gives me will be the k right here. That's k. You can finish that up, unless I'm wrong. Actually, if I turn the page, maybe we'll... I hope I'm going to be right. Let's see, can I do it in my head? Yeah, I think I can. But I don't think I really want to. Not in my head. I'm not using a calculator at this point. Let me know if those numbers come out to... Let's look at the next page. They kept it as a fraction, 9 over 10. And by doing so, they got a 61 over 20. So we just got to figure out if our decimals are the same. Either way, hope we're right. Let me know. Try another one. Okay, this one is asking us to find the domain and range. And guess what? I know the a value is a positive number, so that's greater than 0. Therefore, it opens up. So this time, my domain, guess what? Is still negative infinity to infinity. It's always negative infinity to infinity. It always goes to the left forever and the right forever. It just keeps going up, 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 up. You know, it just keeps going. Now the domain, the vertex this time has to be the lowest value. So I know that my range has to start out with k and then go all the way up to infinity. So he's got to find k. So my vertex is h comma k again. But they were so nice, they gave it to us already in standard form. So if I'm looking at an a times x minus h plus k, I need the h. Well, this is minus 4/7. So that tells me that my vertex has to be 4/7 something plus k 5/11. I'm sorry, 8/11. 8/11. This one was easy. We already have the answer. The range should be 5/11 to infinity. And that's a try it. We don't have our answers. So if I'm wrong, just yell at me. But be nice. Don't make me cry. And I don't think I'm going to. Well, yeah, why not? Look at these pictures. The vertex always tells us our maximum or minimum number. My minimum is the y value. So when I look at this vertex, I see it's at x is 2, but how low is this function? The lowest is a 1. So we say the minimum value is 1. Where does it happen at? X is 2. So if I go and look at the other one, that has to be a maximum value. Because if I go back to the first one, it does not have a maximum value because it keeps going up forever. The second graph does not have a minimum value because it keeps going down forever. So all it can have is a maximum value. And if the y value is 4, that is the maximum value. Let me get my color. The y value is up at 4. That is my maximum value. Where does it occur? At the x value, negative 3. But the maximum is 4. That's what we're doing there. I just told you how to do it. Just find the vertex. Look for the y value. If it's upside down, because the a is negative, then the y value up here, h comma k, k is the y value. If it's right side up, this would be my max. My maximum is at this ordered pair. This is my minimum. Whatever k is, again, same thing. And I don't think I'm going to work on this problem right now. I might save this for part 3. We have enough to work with. Part 3.